Now we look at domain and range for function as graphs. We will write down the domain and range using interval notation. Remember, the domain of relation is all of the input or x values that the relation includes. In order to find the domain of the graph, I want you to look at the endpoints of the relation graph from left to right. We will include all the values in between the two endpoints as long as the graph is continuous. The range of relation is all the output or y values that the relation includes. In order to find the range of the graph, please look at the endpoints of the relation, but this time we are going to be looking from bottom or lowest to top or highest, because the range is looking at my y value, so we are going to go bottom to top on this first function. Notice that we have arrows. This means that the function keeps going to this direction forever to the left and forever to the right. I would like you to first look at your arrows, and if they are going not vertically or horizontally, but we want to call or at angle, I want you to think about each of these arrows as two components. This arrows which is going down into the left is going left forever, but it is also going down forever. The upper arrows going up forever and to the right forever, because it is at an angle, not vertical, not quite vertical, not quite horizontal. So what is going at an angle or forever at right forever? When I'm looking at the domain, I am looking for the endpoint of the relation graph from left to right, or how for left does this function will go. This area right here tells me that my function goes left forever. How for right that this function will, this arrows right tell me that my function goes left forever. So my domain is give infinity to positive infinity. Similarly, when I'm looking for the range, I am looking for as low as my values can go and as high my values can go, and I include all the values between them. The lowest I can go is infinity. Notice that the arrow right here tells me I can go down forever. Similarly, this arrow tells me that I go of upper when I am looking for my range. How low can I go when negative infinity? How high can I go positive infinity? On my next function, I have again this arrow that are going off at an angle. This arrow on the left hand side tells me that I am going up forever, but that I'm also going left forever. It may be going up a lot faster than it is going left forever, but I need you to understand that that does go left forever. Their direction, this angle is going to going and left forever. The other arrow is going up forever and right forever. To look for my domain, I am looking for how far left can my function go and how far right and my function go. Well, this arrow here tells me my function go forever left, and this arrow here tells me my function can go forever right. So my domain is negative infinity, comma, positive infinity. When I am looking for my range, both these arrows tell that I am going forever, although I don't go down forever. So I need to really look for my lowest point, comma, my highest point. Well, how on my x-axis do my value start? It looks like my y value start right here at -1. And how high do they go? Will they go up forever? I am allowed to include -1, so I use a bracket. I am not allowed to include infinity, so I use, and that is my range. On the next function, you have to be a little bit careful. These arrows are pointing down forever and also left forever. The next arrow is also pointing down forever, but it is also going going right forever from the left. This arrow here tells me it is go left forever, and this arrow here tells me it is goes right forever. My domain must be negative infinity, comma, positive infinity, although my range has two arrows pointing in the same direction. They are going down forever. What is the lowest value that my range has negative? Infinity, because both of those arrows are telling me that I am going down forever. How high is my function reach on my y-axis? I am looking for the highest value, and the highest value that I see is right here at 1, 2, 3. At 4, the lowest value can be as negative infinity, comma. On the next graph, notice that we don't have any arrows at all. We have on endpoint on the left, we have endpoint on the right. So when I am looking for my domain, I am looking how far left can my value go on the x-axis, and how far right on my value on the x-axis. It looks like my function start on the left -3 and it ends on the right at +4. The lowest my value on can be in the x direction is -3, comma. The highest my value can be and the x direction is +4. Can I included my -3 absolutely, so I put a practice and can include my 4. So I put when I am looking for my range, I am looking for the lowest the value can be on the y-axis, and the highest that what value can be on the y-axis, not necessarily the endpoint of the actual graph, but the lowest it can be, comma, the highest it can be also. When I am looking at my y-axis, the lowest value on my y direction is 0, comma. How high can it be? Do I stop here because that way my endpoint is well? No, because I have more y values higher than it one. I can go all the way of from 0 to 1, 2, 3, 4. So my range is 0, 4. Can I include 0? Absolutely. That closed point. Can I include 4? Absolutely. That also closed. On the next two graphs, we have this dot line through the middle of the graph here. This may be your first introduction to this dot line called and will be using several times this. So this is a good place to introduce this. This graph gets really close to your symptoms. Also, it is never reach your symptoms, and that will be, does it boundary line for your actual graph to the actual graph is the flux line. The blue dot lines are only one boundary. So to let the recorder now here the graph is approaching to it and not ever crossing, and that what is. Let's look at this first function again. We have arrow, so I am going to look at the arrow and say this vertical arrow goes up forever, but it does goes left forever. It may be look it's going straight up, but it is really continuing out. Go left forever, even though going to ever faster, it does continue to get left forever. Now the other arrow is only going right forever. It will not continue to go down forever because of the dot line to the dot line tells you that the line will never go below that value. When I am looking for the domain, how far left can I go? How far right can I go? To the arrow it tells me that I am going left forever, and this arrow tells me that I am going right forever. So my domain is negative infinity, comma, positive infinity. When I am looking for the range, I am looking at the x-y axis. How can my values go on y-axis? How high can my values go on the y-axis? My value start at 0 and they continue all the way up forever, because that what that arrow tells me. So my range is 0, infinity. We know there is an all infinities, but the question here is, do I choose brackets on the 0, or do I use well, that goes back to the definition of the line width of the function and the range, and I am looking for will never ever cross or reach the, so it will never ever reach 0, but it gets infinity close to 0, which means 0 is my endpoint yet not included. So we use on the last graph. Let's look at the arrows, because we have the left arrow is only going left forever. It will not continue to go forever. It reaches its boundary point at the asymptotes. Similarly, this arrow goes from down. It will not ever cross the asymptotes, so it does not go right forever. Similarly, this one goes up forever, and this one goes right forever, but will not ever cross the asymptotes. When I am looking for my domain, I am looking for how far left can I go, how far right can I go. Although I have problem here, because my two branches of my graph are separated by asymptotes, I can have all the value very right up until my asymptotes at -1, and then I can have all the values to the right of negative. But I am not allowed to have value negative. When the definition of an instance says my graph gets infinity close to but not across it, my domain would be negative infinity all the way up until -1, not included -1, union all the value from 1 to infinity. This means all real number except negative. I make that -1 right there. My range is very similar to this arrow, so I go down forever. This arrow says when I go forever, but when I am not allowed to have is my asymptotes at -2. I am allowed all values below -2 all the way right up until asymptotes, and then I am allowed to have all y values above -2, but I have 4 right here at -2. Therefore, my range is infinity all the way up to the -2 union -2 until infinity.